Today let's talk about the quotient rule for differentiation. Now the quotient rule is used to find the derivative of the division of two functions, assuming both functions are differentiable. So here we see the basic formula for the quotient rule. You got your two functions here being divided. Let's take this formula and run through a couple examples. So I'll keep the formula here just so that we can reference it. Let's say we're trying to find the derivative of x cubed over 1 minus x to the fourth power. So here up top we have our f of x function, seen here. And down here we have our g of x function, seen there. So what do we need to do first? Let's just go ahead and set it up. Let's put our g function right here, and we need to take the derivative of the f function, x cubed minus the f function times the derivative of the g function, and that's going to be all over the g function squared. Okay, so now let's solve. We have 1 minus x to the fourth, that stays there. The derivative of x cubed, we're going to need to use a power rule. So we're going to move the 3 down here in front of the x and then subtract 1 from the exponent. So that's going to give us 3x, 3 minus 1 to the second power, minus just our f function, x cubed, and then the derivative of our g function. So 1 is a constant, we can ignore that, keep our negative sign there, and then we're working with another power rule. So go ahead and move our 4 down there, subtract 1 from the exponent, we have negative 4x, 4 minus 1 to the third power. And that's going to be all over 1 minus x to the fourth squared. Now let's go ahead and simplify this. So let's distribute our 3x squared into each one of these terms. So we have 3x squared minus 3x to the sixth power, because when you're multiplying exponents like we're doing here, you're just going to want to add these together. Now let's multiply this side. So we have negative x3 times negative 4x to the third power. This is going to give us positive 4x to the power of 6. Again, we have two terms with exponents, so we're just going to be adding the exponents together. And that's going to be all over 1 minus x to the fourth power squared. Now we can go ahead and combine like terms. We can simplify further. So we see up top we have two terms that are raised to the sixth power. So we can combine those. So we have 3x squared, negative 3x to the sixth plus 4x to the sixth. That's going to give us positive x to the sixth power. And again, all over 1 minus x to the fourth squared. And that's our final answer. It's perfectly fine to leave it like this. Let's do another quick example. So say we have x squared plus x minus 2 over x cubed plus 6. Again, this is our f function, and this is our g function. So we're going to be solving x cubed plus 6 times the derivative of x cubed times the derivative of x squared plus x minus 2 minus x squared plus x minus 2 times the derivative of x cubed plus 6. All over x cubed plus 6 squared. So go ahead, if you think you can solve this, pause the video and try it out. So we have x cubed plus 6 And for the derivative here, we're using a power rule here. So it's going to be 2x to the 2 minus 1 power. So it's going to be 2x to the first power. That's just going to be 2x. And then for the derivative of x with respect to x, that's going to be dx over dx. And that's simply going to be 1. So we have plus 1, and negative 2 is a constant, so we can ignore that. Minus x squared plus x minus 2 times 3x to the second power. And 6 is a constant. Get rid of it. All over x cubed plus 6 squared. Now we got a little bit of work here to do. We have to distribute everything and simplify the numerator. So up top, using FOIL, we can simplify this out. So then we get to this point where we can now combine like terms. So this is going to give us negative x to the fourth power minus 2x cubed plus 6x squared plus 12x plus 6 over our denominator. So that's the quotient rule. We went over a couple examples. Hopefully you got something out of it, and thanks for watching.